Welcome back to your Numpy learning journey. Now, in this session number 3 in this Numpy series, today we'll be discussing some of the important properties and the operations that we can do using Numpy array objects. In the last session, you have seen how to create an array and what are the various methods that we have which will help us in creation of arrays in an efficient manner. Now, as we progress in learning journey today, we'll understand the more properties of the NumPy array and how to perform the operations between the NumPy array objects. So let's get started. Now, in the last session, we have seen how to create a NumPy array. In order to create an array, first we'll have to import the NumPy array library as a shorthand notation as NP. That's a general practice, and we can create an array using np.array function. And we've got various methods inside this NP, that is the NumPy library, to help us create the array object. So this is what we know from the last session. So once my object is created, that is once my NumPy array has been created, I can go ahead and work with this NumPy array object. Now there's one thing that I want to add in today's session. If you remember, whenever I wanted to generate any array, we had made use of np.random module. Using that random module, we were creating the array object. Now, since we are generating the array each and every time in a random manner, we want to ensure the repeatability or a reproducibility. In order to set the reproducibility, we make use of np.random.seed. So np.random.seed is a method that we'll be using to ensure the reproducibility and the repeatability of the NumPy array. If we specify this np.random.seed and then call the random module, this will ensure that no matter who is going to run the output, everyone is going to get the same output. And that's the best part of this np.random.seed. Now, once my array has been created, I can now go ahead and call its various properties or the attributes. Here we've got the ndim attributes. This is going to return the number of dimensions that we have in the array. We've got shape attribute. This is going to return the shape of my NumPy array. We've got size attribute. This is going to return the total number of elements. This is going to return total number of elements in my NumPy array. So this is the importance of these three important attributes. So I've got the x3. If you come back, see my x3 is having the shape as 3, 4, 2. Now if you observe, when I say x3.ndim, I've got the output as 3. x3.shape, it's a 3, 4, 2. x3.size, in total we've got 24 elements. So this is the total size of an array. Okay. Now, apart from this, we also have other attributes. So the other attributes that we have in the NumPy library are this item size. This is going to return the size in actually bytes. So, okay, it is going to return the item size in bytes of each array element. Okay. And we've got n bytes. This is a special attribute which will return the total size of my NumPy array. Now, in this scenario, 8 bytes is the size of my individual element, and 480 bytes is the total size. Yes, it's the total size that I have right now. Okay, next, moving on. Once my array has been created, I can shape it as per my requirement. And this shaping of the array is called as reshaping the array. Now, while performing the reshape, okay, one thing that we have to ensure is that we have to ensure that the number of elements in my original array is same as the new array which I'm trying to reshape. Okay, now here in this scenario, the np.arange 1, 10, this is going to have 9 elements because 1 is included, 10 is excluded, and I'm reshaping it to the shape of 3, 3. So I'll have 3 rows and 3 columns. So as a result of this, you can clearly observe that my one-dimensional array has been converted to two-dimensional array with the help of reshape method. Now, this is an illustration, guys, where I'm converting my one-dimensional array into a two-dimensional row or a column matrix. See, this is an example of row matrix. This is an example of column matrix. And I can add a new dimension as well by making use of np.access. Okay, here I have added a new dimension by making use of np.newAccess. This has added the dimension along the index 0, and this has added the new dimension along the index as 1. Okay, so this is how we can increase the number of dimension of an array. And once my array has been created, if I want to combine both the arrays, then we've got the option to concatenate. Here I've got the array x and y. In order to perform the concatenation, we have called np.concatenate x comma y. So this will perform the concatenation along the rows. Okay, that means it will place one next to the each other. So by default, my arrays will try to place it one next to each other. And if I want to perform any concatenation along one below the other, then in such scenarios, we have to perform an activity that we actually call it as an access. By specifying the access, we can perform the concatenation as per our requirement. Now to get the better illustration on this, let's take up an example. Let's say I've got a two-dimensional array, which is my array 1 that looks like this. And here I'm saying that np.concatenate array1 comma array2. So in the scenario of my two-dimensional array, by default, it will be placed one below the another. If I want to place one next to each other for a two-dimensional array, I'll just have to say axis is equal to 1. This will concatenate and it will place one next to another. So if I set axis is equal to 0, it will perform the concatenation along the row axis. If I say axis is equal to 1, it will perform the concatenation along the column axis. And that's the role of performing the concatenation using the various axes. Now here, if I'm working with the array and if that is having a mixed dimension, then it can't be clear. So it can be clearer with the help of this np.vstack and np.hstack function. So I can make use of these functions and perform a vertical stack or a horizontal stack of my NumPy array objects. Now, in order to get the better understanding of all this, let's go back to our Google Colab notebook and let's start implementing it in an hands-on manner. So I'm back to my Google Colab notebook. This is the same notebook which we were working in the last session. So I'll just use the same notebook. Now let's go ahead and let's start working with this. See, first thing that I'll be doing right now is here an array is getting created. I'll just copy and paste it over here and I'll assign to a variable. I'll say a is equal to and I'll assign to a variable and I'll print my a. Now once I execute this cell, see, I've got an array which has the shape as 2, 3. So this is filled with the values, that is the random values between 0 to 10. Okay, now here, observe closely guys. If I execute it again, each time when I execute it, now I have the values as 294987, and if I execute it again, I'll have a different set of values 477940, which means each and every time that I'm executing it, I'm getting a different output. Now this means if someone is running my code, he'll not be getting the same values that I'm getting. So in order to ensure the repeatability, as we have learned, we have something called as random.seed, and here I can mention any value. Okay, I can mention any value. Now I've mentioned as 0, which is a random number. It's just an integer. Okay, so now if I execute it, no matter how many times that I'll be executing it, I'll get the same output. And this is the benefit of random.seed. So this is like saying that every time that I tell you this, you go ahead and generate these values. So that is the usage of np.random.seed. Now once I create my array, I have the various attributes. I can call the shape attribute. It is going to describe the shape of my NumPy array. So this is a two-dimensional array. I've got 2 rows and 3 columns. That's the shape. And when I say size, this is going to return the number of elements that we have in this NumPy array. We've got 6 elements that we have in this NumPy array. And here I'll have an attribute that is called as item size. Okay, we've got an attribute that's called as an item size. This is going to return the item size. Now here, the item size that I'm getting over here, it says 1 byte. The reason because my data type is int8, so which is a 1 byte data type. And here, when I say a.n bytes, this is going to return the total size. This is going to return the total size of an array. So in this scenario, I've got 6 elements and each element is of the size 1 byte. So 6 into 1, total number of size of an array is n bytes. So that's the total number of bytes that we have in this NumPy array. Now, after we have learned this operation of getting the shape, size, and we have also got the ndim, this is going to return the number of dimension. So after we have seen all these things, in the video, we have seen how you can reshape an array. So the array shape, that is NumPy array shape, is 2, 3. And if I want to do a reshape, I can simply say a dot reshape, and I just have to mention the new shape inside the parenthesis. See, this has converted into a new shape of 3, 2. Always remember, the number of elements in the new array should match the number of elements that we have in the original array. I can say a dot reshape 4, 3. So if I do that reshape, so here I'm going to get an error. It clearly says it cannot reshape an array which is of size 6 into a new shape of 4, 3. Okay, so this is one thing that you need to remember. And guys, whenever we are working with an array, okay, if I want to add a new dimension, I can add it with the help of the reshape method. Or another thing is we can make use of np.newAccess. To help you understand how we can specify this np.newAccess, I'll create an array A which has the elements as np.arange5. Okay, and this NumPy array A is now a single dimensional array. Okay, so this will be my single dimensional array. Now, if you can clearly observe, I've got the values as 1, 2, 3, and 4. Now on this array, if I want to convert it into a two-dimensional array, I can obviously make use of reshape. Alternatively, I'll make use of this concept of indexing. Okay. Now here in this scenario, I'll simply say np.newAccess, colon. So here, when I do it like this is going to add a new dimension along the axis is equal to 0. So I would say y is equal to a, and if I describe the shape of my y, okay, so I've got the output that says 1, 5. See, this has converted into a row matrix or a row representation. Now when I say z is equal to colon a colon comma np.newAccess, this is going to create a two dimension. Okay, so this is how this z would look like. Okay, next we have learned about the concatenation. So to get the better understanding, let's take up an array. I'll say array is equal to np.random.randint and 0, 100, mention the shape as 3, 2. Now, in order to perform concatenate, I'll just have to call np.concatenate, and here inside the parenthesis, I will say array, array. So this is going to ensure that this will place my array. I'll display my array. See, when I say concatenate, I'm going to place one array below the another array. And if I want to perform the concatenation one next to each other, I'll have to say axis is equal to 1, and this will perform the concatenation where my one array, see this is my one array, I'm placing it next to my another array. So this is how the np.concatenate function is going to work. And alternatively, we have the vstack and hstack. So np.vstack, and I'm going to say array, array. So this will perform the vertical stacking, places one below the another, and np.headstack. So this is going to place one next to another. So this is how we can perform the concatenation. So as part of your learning journey in this video, you have seen how to work with NumPy arrays and the properties of the NumPy array, perform the various operations such as concatenation, reshaping, horizontal stack, vertical stack, all those things that you have learned in this video. So thank you so much guys for staying with the end and watching till the end. For the source code, please check out the description. And for more information, comment us in the YouTube channel. So thank you so much for watching. I hope you have enjoyed it. If yes, do show your love by saying it as you have enjoyed it in the comments tab. So it really makes us happy. Thank you. I'll see you next time.